All right, STEMmies. So, we know that last week you had a lot of fun. I'll wait till everybody's on their bottoms with their hands in their laps. So we know you had a lot of fun with water last week, so we thought we'd do some water again this week. Yay! That's all we did. Surface tension. So last week you had to float boats on the surface of the water, and today we're going to be talking a bit about surface tension. Turn and talk. What do you think that means?
What the word tension might be.
Soup water.
Look at the power bottle.
It means like something can like stay on top of the water. It's like staying on top. Spider walking on water.
So what do you think surface tension is?
Like stuff that can stay on water.
Did you hear Mrs. Portino when you were listening?
We had some scientists over here observing that these pictures here, they saw either something on top, sitting on top of the water, or that the water was kind of cooling and sitting on top of something else.
You had a lot of hypotheses about what makes things float, didn't you? Yeah. And did you find that, does it have to be light for it to float?
No.
No, remember when we piled up those hundreds and they kept on floating? Yeah.
We need to predict how many drops of water do you think a penny could hold?
About 2, 3,
So,
4.
keep your thoughts in your head. Keep your thoughts in your head. Keep your predictions in your head. Here's a penny. You're going to have a penny and a dropper. Okay. And you're going to predict and make a prediction on how many drops of water you can place on the penny and that the penny can hold on top of its surface without falling off.
Why do you think it's going to be hard, Mariana?
Because once you put too much drops on the penny, it kind of spreads out a little bit and then it comes off.
That's awesome.
And she says it's just one big drop.
Did he squeeze 25? Yeah, so it's 25, total of 25, right? What happened to those 25 drops when you put them on there? It squeezed together, made one big drop, but it was 25 little drops, right? And they all squeezed together.
Okay, now hold it up. See if it
51, 52, 53, 54. How did we get 50? We got 55! How did we get 55?
Now, how were you able to do that?
We did little tiny drops.
Little tiny drops.
Were your drops, did you do separate drops or did you drop right on top of each other?
Separate.
Separate drops.
Separate little drops. What did you notice about those drops when you dropped them on there? Elena said it to me. Elena, what did you say to me? What were your drops doing?
It's squeezed together.
They squeezed together. She said, did you notice that all your drops kind of... What does she mean they squeeze together? What does she mean by that? Anna?
They form one drop.
Oh, I love that. They formed one drop. They came together and formed one drop. They were kind of pushing and pulling at each other, pulling really hard because they wanted to stay together. Remember when we read about the surface tension? It says the ones at the top pull really hard to try and stay with other particles like them. Did you see surface tension when they all get...
What do you think, you're going to predict, what do you think adding soap to the water will do? Would it allow you to make more drops on the penny or less?
Sure, and talk.
I think it's gonna add more because when soap is like mixed up water, and the bubbles have air inside of them.
He's been learning about solids and liquids and gases too.
It takes more space because it's more bubbles.
Are you counting?
Yeah, I'm counting now. 1, 2.
2 bubbles in it.
Oh, it has bubble in it?
Tell me that to look at the time.
So what's happening now with the soap?
He's at 50.
Oh.
It makes
Are there more drops or what's in there?
Air.
Air, that's right. So those bubbles are filled with air, you think?
Out is the water, so it has more drops of it.
Do you think there are more drops? Do you think there's more water than last time? Or is there something else mixed in with it?
Air. So that makes more drops with it. I think.
Let's see, are you counting?
Get more water.
Okay, get some more water.
Did you get more or less with the soap water? Why'd you think?
Okay, 48. We got more. We got more. It's holding me. Oh, this one's gonna get bubbles in it. You can just pull it around. It's pretty simple.
Ben, I had an interesting conversation with you. Did you get more or less with the soapy? Less. And what was your thinking? You had that really cool word, and I forgot what it was. What did you say to me?
They got distracted by the It got distracted by the soap. The water got distracted by the soap, and it started flowing off.
Remember how it said we talked about surface tension? The molecules wanted to hold tight to each other. Ben thinks that the soap distracted them and made them fall off.
Brandon,
And what grade are you in?
second. Elliot, in second grade. My name's Mariana, and I'm in second grade.
Okay. And how do you feel about STEM Club?
Sad that it's almost gone.
Why?
Because I liked it. I like getting wet. And it's fun
What's fun about it?
that you do different fun experiments. I think STEM Club's amazing because, well, basically it teaches me a lot. And what I most like about STEM Club is everyone keeps trying and trying and trying, and they never give up.